Hey, eighth grade, here is a little bit more information or just a reminder of the stuff we did today with the best fit lines and residuals and all that stuff that we've talked about. So we're looking at number 4. So this is number 4, and I've already put in the information. So I'm going to show you a couple of things here. First thing I'm going to do is I'm going to use this equation, which does this. Now, I want to show you everything that's on here when you enter this first. First of all, it shows you right here, we talked today about the r squared, that was the correlation coefficient if you use the square root. Well, if you put in your table right away and just use this equation with the squiggly line, then you get right here the r. It does the square root for you. Negative 0.607. And it might have the plot button for residuals next to it. If it does, you should hit that because then you'll get the residuals down here. And, you know, they do look kind of like a random scattering, so that's what they should look like. It automatically gives you the m, the slope, and the y-intercept of 102.53. So if it asks for the equation, well, my equation would be y equals negative 2.75 x plus 102.53. So if you look at my answer sheet here, you notice that's exactly what we have. Y equals negative 2.75x plus 102.53. Here's the correlation coefficient, negative 0.6071. That's it. Now, another way to do this, however, is to go back to our regular old slope-intercept form, and you get y equals mx plus b. So there's the slope, there's the y-intercept, and I'm going to put all my sliders in here. And let's see what we can do. First, let's get the slope kind of matched up. I don't know. If I use the one the book said, just don't know if I like that one as well. I need to get it up there though. Now here's the thing, is like I'm trying to slide it over there and I can't. And if I go in a little further, it looks like, if you think about that the b is the y-intercept, it's going to have to cross somewhere between 60 and 120. So I'm going to tap right here on the number 10. I'm going to make that 120 and make the other number 60. Somewhere between 60 and 120. Now, maybe I can get this line to match up a little better. Like that. That's looking pretty good. Maybe a little sharper. About. And I'm just going to keep doing that till it looks like a good fit. Now, I like that one. It's not too bad. The numbers here are definitely different than this negative 2.75 for the m and the 102.53 for the b, the y-intercept. But let's now see how well my new line fits. So now I put in y1 squiggle plus b. All right. Now, the only thing I get this time, I still have the residuals down here. Whoop, a little too much. Still have the residuals. Still looks like kind of a random scattering. Now I have this 0.0868 for r squared. It does not give me the r, so I'm going to have to use a calculator. And remember my number, 0.0868. All right. That would be a 0.0868. And I need the square root of that. Yep. And that'll give me 0.294. Whew, not good. That's way too low. Remember, it needs to be between, like, closer to 1 or closer to -1. So, does not like that one for a best fit line. Now, if I leave this here, I can make adjustments and see if I can get closer. It's not too bad enough. If you watch down here as I move the slider, this is getting closer. You'd really like it to be a 1 or a -1. So as close to that as I can get. Let's see. Ooh, that was really close. That's pretty close right there. So now I have a -5.8 and a 106.3. Now, if I take 1.08, and I do the square root of that, that's a 1.04. That's a pretty good one. So actually, my best fit line fits the data better than just doing it with this equation first. So now let's look what we have. If we're going with y equals mx plus b, my m is right here, my b is right here. So my equation now is y equals -5.8 x plus 106.3. And that gives you the correlation coefficient of 1.04. That is even more accurate than what they have. Now, let me save this one. And let me open number 5. Now here's number 5. I'm going to go through the same thing. I'll try to go through a little faster this time. Now I'm going to start here with what the book does. y1 squiggle mx1 plus b. All right. Now this one's not bad because you notice it's a 0.90. That's pretty good the way it is. You might say, hey, we're good here. And they give us the m. The slope is 3.54. And the y-intercept is 19.679. Let's look at the answer. You notice there it is. Y equals 3.54 x plus 19.68. And there's the correlation coefficient, 0.9007. This one's pretty good already. Still, we can go back to this. We can put all of our sliders in. And we can see how well we could do on our own if we can get better than 9.90. That's going to be a tough one. I'm going to put it right about there. Let's see. Let's go this way a little bit. All right, now, I think, I don't know. Let's tilt that a little bit. I like it more there. I think I'd like, well, maybe I should be too picky. All right, now, put in the ones I like. Now I go back to this. All right. Looks like nicely scattered residuals here. And 0.08. Yeah, see, that one doesn't look like it fits well because that's not. Let's see if we can make any adjustments and make this number, the r squared, go up higher. We want that r squared one even to be closer to 1, because then the square root will be around 1. And that's the wrong way. Ooh, that's getting cool. Nope. Nope. Let's go the other way. Nope. It's worth a shot. I was close there for a little bit. Right about, ooh, I had one almost perfect. See if I can get it down to, it was 1.01 there for a second. I'm sure this is the most thrilling video you watch for a while. Okay, I'm going there. So right now my equation would be y equals 8.4x plus 9.3. And that my correlation coefficient squared is 1.01. All right, let's see what that looks like. 1.01 square root 1.00. Whew, it's pretty good. So mine was 8.4x plus 9.3. Theirs was 3.54x plus 19.68. Now, you might be saying, why are my answers closer to 1 than the book? Well, the book is using a specific kind of function on a graphing calculator that does not have the same ability to adjust like Desmos does. So we're able to get more exact on ours. And our stuff looks pretty good. Now, one of the questions that'll come up is, it'll say, now predict how many, what was this one even about? Predict how many, I doesn't have it on there. Predict how many of whatever. And so they'll give you like an X. And so when you get this, when you get your best fit line and you have your slope and your y-intercept, and if you go on your line up here and you can say, okay, I'm going to make a prediction, which means I'm going to hold there. So if it was like, how many at 9 years or whatever, and you go up here till you get to a number that's 9, which would be, looks like about right here. Yeah, sure it is. 10. So I'm holding on my best fit line until I find the right, that's pretty close, up a little bit right there. So if it was something about 9 years and, how many burgers you've eaten or whatever, and if you find your best fit line that works really well and you hold on the line, there's my ordered pair, 9, 84.9. So your prediction based on your best fit line is 84.9. And that comes up in some of the other problems. So hopefully this will help you a little bit to see how to do this. At the very least, if you just want to say, hey, what the book has is good enough, you're going to put in this equation. If you want to be more fine-tuned, you can use this first, adjust your sliders, and then see how you get. All right? Give it a shot and see how it goes.